My name is Joe Barrow. Welcome to Ridgetop Group, and today I'll be taking you through a demonstration of Sentinel RingDown EPU, Power Prognostic Unit. Sentinel RingDown was designed with two primary objectives: to provide an accurate advance notice of an impending power failure in a power supply circuit, and also the qualification of a power supply before its actual implementation. The technology applies to both mission-critical and non-mission critical applications alike. For mission-critical applications such as dialysis machines for medical devices, or missile systems, for example, whose failure could result in catastrophic loss and in some cases even death, this sort of detection is absolutely critical. For non-mission critical applications, such as hybrid batteries in electric vehicles, or batteries in our everyday electronics such as laptops, failure in power supply could result in the loss of data, unnecessary maintenance, and an overall increase in unnecessary costs. And now for a demonstration of RingDown. Included in every RingDown evaluation kit is the power supply, the daughter board, power cord, USB cord, accompanying software, as well as an installation and troubleshooting guide.
To start using Sentinel PI, you will go to the Windows Start menu, All Programs, Sentinel PI, and click the Sentinel PI logo. Once the Sentinel PI window is opened, you will go up to Experiment, New Experiment. You can leave the default setting of RD1000 for the experiment, move to the next screen, and leave the default New RingDown experiment. Once in the New Experiment window, you will want to set your experiment to auto scale, and then set your loop to loop every 1 second, and begin collection. You will see an initial ringing response of the healthy power supply. When you have finished looking at the healthy response, you can inject different types of faults. The first fault we'll look at is the amplifier fault. To synthesize a fault, you check mark the Synthesize Amp Fault box, and you will see a change in the ringing response of the power supply. As you can see, an amp fault causes a very overdamped response of the supply so that it returns to regulation more quickly than would be expected. Next, we will look at an individual capacitor fault. You will want to uncheck the amp fault and then check the capacitor fault. The first fault, the minor, you will see causes an underdamped response to the regulation. You can increase this capacitor fault step by step using the radio buttons in the capacitor fault area. As you can see, each fault causes a more and more degraded response in the power supply. The final response actually drops the power supply out of regulation so that it no longer regulates around the 5 volts, but actually drops it into approximately 4.8 volts. After that, we will look at compound faults. You will want to leave the capacitor fault clicked and return it to the minor capacitor fault setting. Then you can look at an amp fault capacitor fault combination, which we will see actually returns the power supply closer to an overdamped response. If you look at the moderate capacitor fault with the amplifier fault, you will see that it is very similar to the standard response of the power system. And that is the complete demonstration of Sentinel PI for RingDown.